Hi everyone, let us solve today's problem of the day, that is shortest common supersequence. What does the question state is that given two strings x and y of length m and n respectively, find the length of the smallest string which has both x and y as its subsequences. Okay, so note that x and y can have both uppercase and lowercase letters. So what does the question state is that we have two strings x and y and we need to return the shortest common supersequence that we have. So let us try to understand what exactly is a shortest common supersequence. So for example, this is a very standard problem of dynamic programming, and the prerequisite for this problem is that you should be familiar with DP, and also there's a question named as LCS. So this is a sub part, or it is quite, this question is quite similar to that problem. So we'll be seeing it. So, what exactly is a super sequence? For example, we have x equal to abcd and y equal to xycd, right? So, what is the shortest common super sequence that we have? That is abxycd, right? So, why this? Because this particular string of length 6 has both the string x and y as a as a subsequence, right? So basically a sorry so basically a b x y c d contains all these all x x characters and y characters in the same order. See why? Because a b c d, so a b and c d, so it the string x is a subsequence in this particular answer string, and y is equal to x y c d, so x y and again c d is one of the subsequence in this particular answer string, right? So for example, we have e f g h and j g h I. So in this case again we have the supersequence as e j f g h I. So why this? Because this particular answer has the shortest common super sequences, including both x and y characters, and this is the shortest form till which we can go, right? So why? Because EFGH is present in this. We can see E, F, and GH. Okay, so all this is present, both of the strings are present as a subsequence in my answer string, right? So how can I create a super sequence? Or super sequence is basically a type of string which contains both whichever string we are considering, both the string as its subsequence, right? So what how can I start creating a super sequence? Is by, first of all, we have two strings, right? So what is the utmost length, or the longest length that I can achieve, is by adding x plus y, right? If I add both the strings, if I concatenate both the strings, right? If I concatenate both the strings, so whatever string I am getting, it will have all the characters in the same order of x, as well as all the characters of in the same order as y, right? So for example, abcd, it is the x string, and xycd again is the y string. So I can say that this is also one of the super string that I can consider, right? But what we need to give in the answer is the shortest common supersequence that can be achieved. So we know that somewhere we have to reduce this length, right? This is of length 8 which I'm achieving by adding both the strings, and this is a super string, right? So I have to reduce this particular length in order to get the shortest common supersequence. Okay, so for example, we have a b c d and x y c d. So what is the common element that you can see in this particular strings is cd, right? So cd is a common subsequence which is occurring, the characters like c and d are occurring in both x and y string and in the same order, right? So why do we have to consider it two times in my answers string, right? So see, in order to reduce the length, we need to eliminate the characters which are occurring two times, right? So for example, we have c and d, right, in both x and y strings, and again in the answer string we have cd once and another instance of cd. So why do we have to consider it two times, right? So if, let's say, if I eliminate cd over here, or if I eliminate cd over here, eliminate the first CD that I have, right? So what is the string that I will be receiving? I will receive ABXYCD, right? So let us see if I have both the string as a subsequence in this or not. So ABCD is present, right? AB and CD is present in my this string, and again I have to search for XYCD. So XYCD is also present in this answer string. So can I say that this is the shortest common super sequence that I can consider for this particular answer? Why? Because it has a length smaller than the largest, that is 8, and we cannot further divide it, right? uh, yeah, so we cannot further divide this particular or reduce the length of this particular super sequence. So this is what we get, right? So finding the common length, so for example we have EFGH and JGHI, right? So in this particular strings, what is the longest that we can create is of 8 length, right? That is by adding X and Y, both these strings if we concatenate, so that will be the super sequence, a correct super sequence that we can achieve, right? So but we need to reduce the length. So what we can see is what is the common super sequence in both of these strings, that is GNH and GNH, right? So what is the longest that I can get is 8, and what is the common in both of these strings, which I'm considering two times in my answer. For example, if we had this, so in this particular string we were getting 8, right? But we were considering two instances of the same characters, C and D super subsequence, we are considering it two times, right? So in this case we need to reduce this, or we need to remove one instance of CD in order to get the shortest common super sequence, right? So in here also if we remove one instance, we will get, so that is 8 minus 2 that we are doing, right, in order to get a 6 value, that is the length of the common length of the shortest common super sequence, right? So you might have got an idea till now that what we are doing is that we will find the length of the longest super sequence that we can create, and that is X plus Y, that is the length of first string and the length of second string. If we add both of them, that will be the length of the largest common sequence that we have. And after that we need to subtract one instance of the LCS, or LCS is longest common subsequence, that is present in both of them, right? So what exactly is the longest common subsequence, that you should be familiar with, you should be familiar with it before coming to this video, because this is a kind of very similar problem to LCS. So what we will be doing is we will be adding, so for example we have this, right? So this is what I've explained. We have X and Y, and the LCS is CD in this case, right? CD is LCS, that is the longest common subsequence, and that is of length 2. Okay, so we will uh, add both its length, because that is one of the valid super sequence that we can have, and subtract this LCS value in order to get the 6 value, that is our answer, right? In the same similarly here also we have G and H as the longest common subsequence, so we'll be subtracting its length in order to get the value. So this particular formula we will be requiring in order to find the solution. So I will go through the code once. So this is the code that we have. So you might be familiar with it. So I would suggest first go through the LCS problem and then come back to this video. So what we are doing is, see, this is the particular answer that we are returning. That is n plus m minus x. So what is n? N is the length of string x. M is the length of string y. And x is the length of the longest common subsequence that I can have. So this particular solve solution gives the LCS, finds the LCS and returns the LCS value. So what exactly we are doing in LCS, we are passing in the coordinates from where we are starting. Okay, so that is from 0 0 we are starting, and we will go through all. So 0 here is the index of the first string and the index of the second string. So I'll be explaining briefly how we find the LCS of two strings. Okay, so for example we have ABCD and XY, XYCD, right? Okay, so for example we have these two strings ABCD and XYCD, right? And you are standing at this particular index. you have taken two pointers and you're standing at both their first indexes, right? So in one case, I there are two situations, right? There can be two cases. Either a can be equal to x, right? Either both the characters at pointer 1 and pointer 2 can be equal, or either they cannot be equal, right? Either they can be equal or they cannot be equal, right? So what if they are equal? Okay, what if they are equal? So if they are equal, for example, if my pointer was at c and here c again, so since they are equal, that means I have got one length value of my lcs, right? And I need to search for the rest of the strings in order to get my other values, right? So that is what we'll be doing. For example, if I'm at c and here also in the pointer to place we have c, right? So if they are equal, that means I've got one length of string of my lcs. I will add one to my answer and I will search for the other string, for the remaining string, in order to get any common characters. Okay, so but what if we don't have the characters as equal, right? So what if the characters are not equal? So for example, we have a and x. Okay, so either this a can match in the rest of the string, or either this x can match in the rest of the string, right? So in that case, we will be iterating through both of the subsection. So once I will increment the I one first pointer, and another instance I will increment the second pointer. Okay, so I hope you're clear with this gist about lcs, but you have to be sure enough what lcs is and just go through the problem once. Okay, so this is what we are doing. If it is not following the constraint, that is, if I pointer is going out of the boundary, this is the out of bound cases, wherein the string 1 and string 2 which we have two pointers, if it is exceeding our boundaries, we can return 0, right? And what if both of the characters are equal, right? So that is what I stated. If both the characters are equal, what I can do is I can return 1 plus solve of the rest of the string, right? I am incrementing both the pointers. Why? Because I have got one value of my lcs, right? And if they are not equal, then I can either increment first pointer or increment the second pointer, right? Why? Because the answer can be in my this string, like a can match in this particular whole string, or x can match in this particular whole string. So that is what I'm considering, all the cases, yeah, both the cases. And we will return the maximum because we need to find the maximum common subsequence that exists between both of them in order to get the shortest common supersequence, right? So whichever value is returned by this function will be subtracted from both its length in order to get the length of the shortest common supersequence. So I hope you're clear with this question. Thank you.